Okay, so after scoring a touchdown, Alvin Kamara throws the football up to a fan seated in the stands with an initial velocity of 7.32 meters per second. The ball reaches the fan and is caught by the fan momentarily 9.41 seconds later, but the fan fumbles it and drops it straight back down to the field at the feet of Kamara. What is the final velocity of the ball when it hit the ground, and how long did it take for the ball to hit the ground? So, pretty much, I just drew a little diagram of what's essentially happening. So you see Kamara, he's essentially throwing the ball straight up to the fan in the stands, and then the ball is caught by the fan, and then the fan immediately fumbles it. So we have an initial velocity of the ball when Kamara throws it at about 7.32 meters per second, and then we have a final velocity of 0 meters per second. Whenever the fan catches the ball, the velocity stops, and that the time from the ball to get from Kamara's hands to the fan is 9.41 seconds. And so we know on the way down that there is an acceleration of negative 9.81 meters per second squared, which is due to gravity. So we're trying to figure out what the final velocity is and how long it takes for the ball to come down. So what I did here was I wrote out the formula for final velocity, and you see in the formula we need to know the distance or the displacement for the ball to go from Kamara to the fan or from the fan down. It really doesn't matter what you solve for because the distance to go up and the distance to go down for the ball is the same. So we have to find d first to figure out what the final velocity is. So d equals 1 half vf plus vi times t. So we just plug in everything we already know. We know that final velocity is 0, initial velocity is 7.32, and 9.41 is our time. And then when we solve that and plug it into our calculator, we get about 34.44 meters. Using that, we use the distance and plug that into the equation for final velocity. And what happens is that we get about 25.99 meters per second. Well, what you have to understand is that we made the distance negative because in this case we're using it as the displacement. And it actually makes sense because the ball is coming down from the fan to the field. So it's going, the negative shows that the ball is traveling downwards. It doesn't make sense if it's positive. So we get negative 25.99 meters per second as our final velocity. And then the second question, which was how long did it take for the ball to hit the ground? So what we do here is we set up an equation for time by using our earlier equation of d equals 1 half vf plus vi times t, and we plug in negative 34.44 for d and negative 25.99 for vf. So we solve that, and then we get 2.65 seconds for t. And so that's the time it takes for the ball to come down from the